Imagine you're playing with a remote-controlled car. You press the forward button to move the car forward. Your remote generates a radio signal which is received by the car's receiver. This received signal turns a switch on that sends current to the motor. The motor spins the wheel and the car moves forward. But wait, how does this weak signal turn the switch on physically? Don't you need another motor to turn that switch on? So how does this signal help to provide current to the motor? Transistors. First of all, let's be clear that this is not how remote-controlled cars actually work. There are more complicated components that are working to make it possible. That example was just to give you a sense of curiosity on how basic components of an electronic system work. A transistor is basically a switch or amplifier that can amplify very small voltage signal to a high voltage current, and they are very small. So they are not like the switches that we are used to using. They don't need to be turned on and off physically. Have you ever wondered how we humans have come to this technologically advanced world where people can communicate and share ideas and information with anyone? The transistor lies in the heart of all those technologically advanced devices that have affected our lives in unimaginable ways. In fact, transistor is one of the main discoveries that have made humans technologically superior species. To understand transistors, we need to understand semiconductors, the substance that transistors are made up of. Pure silicon helps to make semiconductors. One silicon atom contains 4 electrons in its outermost shell. So this atom shares each electron with 4 other silicon atoms, forming a tetrahedral crystal. This is the structure of pure silicon. To form semiconductors, this pure silicon has to be injected with some impurities like phosphorus or boron. This process is called doping. Phosphorus has 5 electrons in its outermost shell. Its 4 electrons bond with 4 silicon atoms, leaving 1 free electron. So this free electron helps to conduct electricity. Since negatively charged electrons flow in this semiconductor, it is called N-type semiconductor. Coming to boron, it has only 3 electrons in its valence shell. So lack of electrons forms a hole. Other electrons move into the hole and create other holes. So it seems as if the positively charged holes are moving. So this type of semiconductor is known as p-type semiconductor. These two types of semiconductors are connected together to form a diode. After forming a diode, some of the electrons from the N-type semiconductor travel towards the holes of p-type semiconductor. This forms a region with opposite charges on both semiconductors and prevents further flow of electrons, forming a potential barrier. This region is known as depletion layer. When a diode is connected to a battery, it either lets the flow of electricity or prevents it. This process of connecting diode to a battery is known as biasing. When the positive terminal of the battery is connected to the p-type semiconductor and negative terminal is connected to the N-type semiconductor, it is called forward biasing of diode. This repels the charges in the semiconductors, causing the depletion layer to shrink, so electrons can flow to conduct electricity. When the negative terminal of the battery is connected to the p-type semiconductor and positive terminal is connected to the N-type semiconductor, it is called reverse biasing of diode. In this case, the opposite charges attract each other. So this causes the depletion layer to increase in size, so there is no conduction of electricity. Therefore, forward biasing conducts electricity, whereas reverse biasing prevents the flow of electricity. This is the main concept that you must understand in order to understand transistors. To make transistors, 2 diodes or 3 semiconductors are connected together. The transistor with N-type semiconductor in the middle is known as PNP transistor, and the transistor with p-type semiconductor in the middle is known as NPN transistor. In a transistor, one of the semiconductors is heavily doped and called an emitter. The semiconductor that is in the middle is called base, and it is lightly doped. The remaining semiconductor, which is intermediately doped, is called a collector. When you connect 2 ends of a transistor to a battery, either of the 2 pair of semiconductors is reverse biased, so there is no conduction of electricity. The transistor is in off state. If a motor is connected to the circuit, it won't work. Let's add one more circuit with a radio receiver. It receives radio signal from the transmitter and filters it. The positive end of the receiver is connected to the base and negative end is connected to the emitter. Now let's understand this circuit in detail. When there is no signal in the receiver, the transistor is in off state. But when the receiver receives a signal, this weak signal affects the base emitter current. The base and emitter acts as a diode that is forward biased. So the depletion layer shrinks in size and the electrons from the emitter move towards the holes in the base. But since the base is lightly doped, there are not enough holes for all the electrons. So some of the electrons move in the forward bias circuit and most of the electrons emitted from the emitter gets attracted by the positive terminal of the battery and travels towards the collector. This completes the main circuit and thus current flows through the motor, causing it to rotate the wheels. This continues until the receiver receives the signal. When it stops receiving signal, the transistor again moves to the off state. In this way, the transistor allows a weak signal to act as a trigger for a high voltage current to flow. It acts as a switch in the molecular level. As we've mentioned before, this is not the only component in an electronic system. There are more electronic components involved in making these electronic devices work. The transistor is the most important component in an electronic system, and other components like resistors, capacitors, inductors, ICs, transformers, relays, etc. work around the transistor to carry out different tasks. The purpose of this video was not to teach you the basics of robotics or electronic engineering, but to give you the concept of how the most significant component that lies in the core of all the technologies present today works. We hope you learned something from this video. Goodbye and see you in the next video.